In recent years, there has been increased research performed on new and emerging pathogens. The race to find ways to stop the spread of these infectious diseases has also been accompanied by an increase in the number of laboratories handling these organisms. This presentation is intended to highlight biosafety procedures and practices in Containment Level 3 labs to ensure the continued safety of everyone working in laboratories across Canada. In Canada, laboratories are assigned a containment level from 1 to 4. As the containment level increases, so must the necessary safety measures. A lab is designated as containment level 3 when it can handle agents that can be transmitted by the airborne route to produce serious or potentially life-threatening diseases with just a small dose. Containment Level 3 laboratory features are intended to prevent transmission and minimize the release of infectious organisms into the immediate laboratory and the environment. Information on specific operational practices and physical requirements for Canadian laboratories is available in these guidance documents produced by the Public Health Agency of Canada and the Canadian Food Inspection Agency. International guidance for laboratory safety is provided by the World Health Organization. Biosafety is an important component of laboratory operations. The biosafety officer's duties are to manage these issues, which can include performing risk assessments to determine the lab's appropriate containment level and reviewing standard operating procedures, or SOP for short, that are specific to the lab's activities. Facilities handling infectious agents need not only a biosafety program, but also a biosecurity plan in place. A responsible official can be assigned to develop, train, and implement the safety, security, and emergency response plans. As part of a Containment Level 3 lab safety concerns, a health and medical surveillance program needs to be appropriate to the agents handled in that lab. Only people meeting the medical requirements may enter the laboratory. As a standard operating procedure, all Containment Level 3 lab employees receive training specific to the operation and maintenance of the Containment Level 3 facility. They must be aware of the potential hazards associated with the work involved and the necessary precautions that must be taken. Lab supervisors are responsible for training and certifying that employees are familiar with the laboratory-specific protocols and are competent to work in the lab. Records of training must be kept for every employee. In this Containment Level 3 lab, as in many facilities, you access the lab from a main corridor that connects to offices and other labs with lower containment levels. The containment laboratories are separated from all public areas, limiting access to authorized personnel only. Notice that all office areas are outside the containment area itself. Signage also identifies what hazardous materials are being used in the facility and who to contact in case of an emergency. Here in the anteroom is where you monitor and record the air pressure readings. Check them every time before you enter the lab. If there's something wrong with the air handling system, audio or visual alarms will warn you. Before entering the lab, it is important to sign in. A logbook or some means of documentation must be maintained to monitor the entry and exit of personnel from the Containment Level 3 laboratory. To get into the lab itself, you need to swipe your ID card and enter a personal identification number. A double key system, such as this one, can further restrict access. A Containment Level 3 lab has a clean side and a dirty side. The objective of Containment Level 3 facilities is to minimize the release of infectious aerosols from the laboratory. The main point to remember about physical barriers in a Containment Level 3 lab is that no two doors should ever open at once. To ensure this doesn't happen, these doors have an interlock system or appropriate standard operating procedure in place. As each facility's design differs, entering your Containment Level 3 facility should be the subject of a detailed standard operating procedure specific to your facility. Pathogens in a Containment Level 3 lab usually pose an increased risk of aerosol spread. To reduce the potential for transmission of these pathogens, you have to remove all your street clothes, including jewelry and socks, and change into dedicated laboratory clothing or scrubs, including clean socks and head cover. Whether you are required to remove your undergarments depends on your facility's SOP. A word about your respirator. This is your most important piece of personal protective equipment. It has to fit you. You must be fit tested prior to working in a facility to ensure appropriate respiratory selection and use. To be effective, respirators must provide a proper sealing surface on the wearer's face. A powered air purifying respirator equipped with high-efficiency particulate air or HEPA filters should be worn by personnel who cannot wear fitted respirators because of facial hair or other fit limitations. Next, put on your laboratory protective clothing. A solid front gown with tight-fitting wrists and gloves that fit over the wrists. Put on protective glasses and make sure that you have all the material you will need with you before crossing through the shower into the dirty change area. You can either keep a pair of shoes for working inside the lab or wear shoe covers. If you have dedicated shoes, remember they are now considered contaminated, so they can't come out. All these protective clothing layers are necessary for your protection. And for increased safety, a buddy system must be implemented. We recommend that at least 2 people should be working in the Containment Level 3 lab at any time. If that is not possible, other means of monitoring or surveillance must be in place. The integrity of the containment perimeter must always be maintained. As lab workers, most design issues may not be a consideration in your everyday work, but here are a few of which you should be aware. Bench tops and working surfaces should be made of non-absorptive, non-organic material with no open seams. They should have rounded edges that are easy to clean. A cove from floor to wall is a good idea, but what's most important is that the seams where walls and floor meet be continuous. One last thing, all coatings must be cleanable and must be able to withstand chemical disinfection and fumigation. The requirements for heating, ventilation, and air handling can vary depending on the transmissibility of the pathogen that will be handled in the lab. As a general rule, the air in a facility should always flow inward toward the area of higher containment. This is referred to as inward directional airflow. This smoke pencil is one of the tools which can be used in the commissioning and certification of a containment laboratory to verify the integrity of the containment room. It clearly shows the direction of airflow. 100% of the air supplied in a Containment Level 3 lab must come from outside the containment laboratory. The air supply system has to be interlocked with the exhaust to prevent positive air pressurization in the lab, and HEPA filters must also be installed. There must also be an emergency warning system in case of malfunction. As part of their containment perimeter, all Containment Level 3 labs working with pathogens that are infectious via inhalation must have a double-door barrier autoclave with bioseal. As always, an interlock system prevents both doors from being opened at the same time. Also, for easier maintenance, the body of the autoclave should be located on the clean side. All materials that come out of the lab must pass through the autoclave or through some other proven decontamination technology. The lab must also have a door large enough to accommodate whatever equipment needs to be brought into it. Laboratory services means all the infrastructure systems that allow a lab to function. The precise requirements are available in the laboratory biosafety guidelines, but here are a few of the service features that concern you directly. Hand washing sinks, featuring hands-free operation, should be located near the exit of the Containment Level 3 lab or in the anteroom. Emergency lights and a source of emergency electrical power are necessary to maintain all systems that are vital to maintaining containment of the lab. In an emergency, as well as in day-to-day work, you need some way to communicate with the outside, such as a telephone, a fax, or even email. In addition, you need an efficient way to transfer your information and data to the outside. Remember, you can't physically carry anything out which hasn't been properly decontaminated first. This includes paperwork. All lab workers who handle infectious substances run the risk of being exposed to these pathogens, either by accident or through improper operational practices. The objective of these operational practices includes reducing the potential for the creation of aerosols. To reduce the risk of inoculation, it is recommended to avoid the use of glassware and to use plastic materials instead when possible. All accidents must be reported, even minor ones. A small cut, which probably didn't draw blood, or a small splash could lead to a health problem, not just for yourself, but for your community, should an infection occur and spread. In a Containment Level 3 lab, you always handle open vessels containing infectious materials inside a biological safety cabinet, a BSC for short. BSCs provide protection from exposure to infectious aerosols and splashes that may be generated when handling infectious agents. There are 3 classes and various types of BSCs. Different classes of BSCs offer varying levels of personnel, product, and environmental protection. An assessment based on the activities to be carried out in your lab should be undertaken to determine which BSC best meets your lab's needs. Aside from your personal protective equipment, your primary protection in a Containment Level 3 lab is offered by the BSC. Each BSC must be professionally checked once a year. Due to their importance, we will take the time to go over their operational procedures in detail. The first step is setting up the BSC. Turn off the ultraviolet lights. Turn on the cabinet blower and fluorescent lights. Check air intake and exhaust grills for obstructions. Confirm inward airflow by verifying gauges or by some other means. Disinfect the interior surfaces. Always using a trolley, bring your assembled material to the BSC. Load the articles into the cabinet. You should separate them into clean and dirty. Wait 5 minutes prior to starting your work. The second step is actually working in the BSC. For maximum protection against aerosols, you should work toward the rear of the cabinet so the air flows away from you towards the rear. In order not to disturb the general airflow, avoid excessive movement inside the cabinet. And if you do need to reach out of the cabinet, remember to remove your outer gloves first and then move out your arms slowly and perpendicular to the front opening. Always allow the air in the cabinet to stabilize before resuming your work. Keep all discarded material inside the cabinet. Biological materials handled outside the BSC must be contained at all times. And when you are moving material between the centrifuge, BSC, benchtops, incubators, and refrigerators, always use a trolley or a cart and make sure you've decontaminated any material before removing it from the BSC. When you've done your work, allow the cabinet to run for 5 minutes with no activity. This will allow the BSC to purge airborne contaminants. Place all material into biohazard bags within the cabinet. Close any open containers. Surface disinfect all objects that came in contact with contaminated material. Remove contaminated gloves, dispose of them appropriately. Don clean gloves. Disinfect work surfaces and outside of biohazard bag. Regularly disinfect hidden surfaces. Turn off fluorescent light and cabinet blower. Turn on ultraviolet lights and change gloves. A spill anywhere in a Containment Level 3 lab will generate aerosols, increasing your risk of exposure and potential infection. You should be familiar with the SOP detailing the cleanup procedures. That way you will be able to respond quickly, calmly, and effectively in case of a spill. Remember, a spill counts as an accident and must be reported. If there is a spill within the biological safety cabinet, leave the BSC turned on and let the aerosols settle before disinfecting all objects in the cabinet. You should also change your gloves and protective gown before cleaning up. If the spill occurs outside the BSC, stop work immediately. Warn other staff members to exit the lab immediately. Locate the emergency biological spill kit. Cordon off the spill area with caution tape. Remove outer gloves and gown. Shower before leaving the containment area as per your SOP. Make sure nobody enters the facility for the time indicated in your SOPs to allow the aerosols to settle and the air to be exchanged a sufficient number of times. Re-enter the lab following entry procedures and proceed with the cleanup. Your facility's SOP may require that you wear a powered air purifying respirator or other additional personal protective equipment for spill cleanup. If a liquid was spilled, apply fluid control solidifier. Remember to use forceps to pick up and dispose of material appropriately. Use absorbent pads to reduce the chances of splashes when applying your disinfectant. Also, when decontaminating a spill area, always work from the outside towards the center of the spill. And always use the appropriate disinfectant at the recommended dilution and contact time. Always try to minimize air movement to reduce the creation of aerosols. Report the spill to your biosafety officer and complete an accident report. Any materials or equipment leaving the Containment Level 3 lab must first be decontaminated. There are various decontamination methods. The method used depends on the nature of the material you need to decontaminate and the effectiveness against the microbial group in question. It must be emphasized that you need to be trained in all decontamination procedures related to the activities in your lab, and you should refer to the specific protocol developed for your facility before you use any of these techniques. Most infectious laboratory waste is decontaminated using the autoclave. As always, an interlock system prevents both doors from being opened at the same time. You should always use biological indicators to monitor the sterilization process. Please note that you still need to check that the cycle was run properly before you open the autoclave on the clean side. And when processing your biological indicator, you should always include a positive control and keep the results on file. Your facility should establish a routine monitoring program for its autoclaves. Disposal of biomedical waste in Canada is regulated by the provinces and territories, so check with the appropriate authorities in your area. Chemical disinfectants are used on surfaces and equipment that cannot be autoclaved, as well as for cleaning up spills. Choosing the proper disinfectant depends on the microbial agent you're working with and on the disinfectant's practicability, stability, compatibility with materials, and potential health hazards. Gaseous decontamination of the Containment Level 3 lab is only done under particular circumstances, about once a year, for maintenance work and before retesting of heating, ventilation, and air conditioning control systems. But after a major spill, when you have to decontaminate the entire Containment Level 3 lab, fumigation with formaldehyde is currently the most common method. Because of the potential for exposure to the hazardous chemicals used, this procedure should be done only by highly trained personnel. New decontamination technologies, such as vaporized hydrogen peroxide, can be considered, subject to validation and approval from the regulatory authorities. As in any lab, there are also regular house cleaning chores that need to be done, cleaning floors, walls, and disposing of waste. But because of all the precautions in a Containment Level 3 lab, they have to be done by trained personnel using specific procedures and materials while disposing of waste in accordance with the facility's SOPs. The following exiting and doffing procedures are intended to prevent contamination from spreading outside the lab. When removing laboratory clothing, this must be done in a manner that minimizes contamination of skin with potentially contaminated clothing. Before you leave the containment area, make sure that all waste has been properly disposed of. Remove your outer gloves and discard them into the autoclave bag. Remove the protective gown and hang it up if it's to be reused. Wash your gloved hands. Cross into the dirty change room. Remove your boot covers, head cover, respirator, and safety glasses. If you were wearing your personal eyeglasses, decontaminate them before crossing over to the clean side. If you are wearing dedicated shoes, remove and store them. Remove gloves and discard them. If showering is not necessary, wash hands thoroughly. Place socks in dedicated autoclave bag and proceed through the shower into the clean change room. Showering may be required as per your SOPs, for personal preference, or in the event of a spill. As you are leaving, make sure the door closes securely behind you. Sign out and update the personnel board. Here are the regulatory aspects of Containment Level 3 lab design and operation. Newly built or renovated Containment Level 3 labs must first be successfully commissioned and then certified to ensure the facility and operational protocols meet the requirements prior to commencing work with infectious agents. Once in operation, all Containment Level 3 labs must be recertified annually. If you have any questions regarding biosafety, please contact us or the biosafety officials in your area for further details. Remember, knowledge of the proper operating procedures is key to working safely in a Containment Level 3 lab. Thank you for your time, and remember, stay safe.